Okay, guys, so in this video, we are going to work on the learning target. I can match a verbal description in a table with the same constant start value and rate of change. Okay, so again, we're holding on to those academic vocabulary words of that start constant value and that rate of change, but now being able to find them in both descriptions, so my verbal description and my table. So what I see here in this example, it says the Japanese club wants to go to the Japanese Cultural Festival in San Francisco. The cost for each plane ticket is $200. If X is the number of plane tickets and Y is the cost, find the matching equation. Well, in this case, we were finding the matching table. But what I just wanted to look at with this story is those pieces that we find in there. Okay, so I had to zoom out a little bit so I can get my pen back. But I see here essentially the cost of each plane ticket costs $200. And then there's no other cost within this story. So this story has a rate of change, but no constant value. Okay, so we know that I have this multiplicative, meaning $200 for every plane ticket. Okay, so if I come to this table, and it even says here that X represents the number of plane tickets, and my handwriting is terrible. Okay, and then we come over here to Y, and this represents the cost. Okay, I am going to just write on here so you can see underneath my preview. Okay, so what I'm looking at here is that when I buy 0 tickets, guess what? It's going to cost me $0. Okay, but I still have that multiplicative relationship of times 200 because anything times 0 is still 0. Okay, so here I bought 1 plane ticket. Okay, multiplicative relationship times 200, it's going to cost me $200. 2 tickets will cost me $400, 3 tickets will cost me $600, and 4 tickets will cost me $800. Okay, so in this story, I saw that multiplicative relationship, and I also see that multiplicative relationship in the table. So therefore, I'm able to match those representations as saying, hey, both of these represent this same story of buying those plane tickets to go to the festival. Okay, so at this time, what I want you to do is you're going to get a question here in a minute. I want you to read this problem and see if you can figure out what is the rate of change and what is the constant value in this story. Okay, so let's check to see if we were on the right pathway. So it says Sally went to get her car fixed. It cost $50 for the parts and $200 for each hour the mechanic worked on it. Okay, now I can read the rest of this, but this is kind of going into another situation, not another situation, but further into the story. So I'm just thinking about right now, Sally's going to go get her car fixed. Okay, is she going to buy more than one part? No, she just needs the one part for her car. So going back to that idea of underlining the constant value, this is that one-time fee that's going to happen, $50. But then every hour that this employee works, they're going to charge me $200. So that generally tends to be the case where the labor, the work that someone's doing costs more than the actual part when it comes to fixing the car. So in this story, I have to pay the initial $50 just to get the part into the shop, and then $200 for every hour that mechanic's going to work on my car. Okay, so again, I apologize for my handwriting. But here is the table that represents that story we were just talking about, fixing the car. So I paid $50 for the part, and then $200 for every hour that the employee was working on my car. Okay, so here it says constant start and rate of change in a table. How does this table match the story we just analyzed? So I want you to look at this table and tell me how and where you see those same values we just saw in the story problem. Okay, so let's see how you did. So thinking about what that rate in the story was, the rate was $200 for every hour that the mechanic had to work on the car, right? So my X variable here is going to be the hours. Ooh. And my Y variable is going to be the total cost that it's going to be for me to get my car fixed. Okay, so as of right now, when the mechanic is working 0 hours, I still have to pay $50. And why? Well, remember, the guy can't work if he doesn't have the part that he needs. So this $50 was that startup constant cost, the one-time fee that I have to pay for the part just to fix the car. Okay. Then it says after 1 hour that the mechanic is working, they're going to charge me $250. Well, it's not a direct multiplicative relationship here. I'm not paying the guy $250 for every hour. We knew that he was only paying $200. So why is this $250 over here? Well, it's $250 because I'm paying $200 for the hour of work plus that $50 for the part. So we have that multiplicative and that additive piece of plus 50. So what I want you to see here is that as we go up every hour in my table, how much money are we going up by hour? Well, from 250 to 450, that is plus 200, right? And then from 450 to 650, that's plus 200. So I kind of see this change happening in my table, that every time I go up another hour of work, I go up another $200 in my cost for paying for the service for my car. But that $50 is always going to remain as that starting price because I have to have the part to fix the car in the first place. At this point, you're going to go back to Schoology and complete your check for understanding on being able to match story problems to their tables that have the same constant start value and rate of change. Please reach out if you have questions or need some guidance.